So our first speaker is a remote speaker, Lavanya J from Vyoma Systems Private Limited, where she's the CEO, delivering the verification as a service platform for the next generation processor verification device. So over to you, Lavanya. We can see your screen together, please.
Hi, Mike. Yeah,
I
can see. Hi, everyone. Hope you're having a good session. I'll be presenting on the topic of RISC-V processor design and with the tag name of verification makeover. I just want to clarify makeover. We are not making over verification engineers. So let's not get wild over that. We are going to find makeover techniques for the tools and infrastructures that we use for RISC-V verification, and hope that gives us more capabilities, us meaning all the verification engineers out here trying to find solutions for our current existing problems. So the jobs to be done is not going to change for us. We are going to write tests, or we are going to write assertions in the case of formal. We are going to develop test benches, we are going to verify, we are going to debug. So that is not going to change. What we would like to change is bringing in more capabilities to the verification engineers to give them a smile when they do verification. So that is the premise of our talk, and a brief introduction of Vyoma Systems. Vyoma Systems works with RISC-V business and its verification primarily. We provide a cloud-based verification as a service platform for verifying any RISC-V design. We are incubated at a university at IIT Madras in India, and we also are recognized as a startup in the Digital India RISC-V movement by the government of India. Back to the agenda, I'll be briefly presenting how we view the RISC-V business and the verification aspects of it, and we present the makeover components, what we consider has to be changed for us to achieve what we are doing right now, and a use case of SHAKTI processors. It's a indigenous RISC-V processor developed at IIT Madras. So a use case using Vyoma's tools will for verifying a SHAKTI RISC-V design will be presented, and a brief overview of the tools that we have. So what is the RISC-V business? So for any successful design company to grow with using RISC-V processors, as well as RISC-V based SoC components, the first thing that has to be maintained is its quality. So any bug escapes is costly for them, as well as the loss of reputation. So quality is something that is foremost in mind for any RISC-V company to grow and give its mark in the market. Along with that, in order to maintain the competitive edge with the customers, and as well as other competitors, the time to market is also crucial. And that is where their early entry might help them give their leverage in the market. The third most important thing is that a lot of companies are developing RISC-V based solutions or products. So the customization plays a very key role in giving them that market share that proves that their market differentiation to their customers. So three qualities, three pillars that provide the success of any RISC-V company to grow, to establish and grow in this market is quality, time to market, and customization. How does it work towards verification? So in order to maintain quality, it's obvious we need to have a very solid test and coverage quality for all the RISC-V designs. Till now, this has been very proprietary and restricted to the companies that were developing the ISAs. The ISA itself was proprietary for processor development. Now, everybody who wants to build their RISC-V design have to understand that innate knowledge of processor verification. In order to do that, for RISC-V verification, there is that added responsibility that the quality is maintained through the tests and the coverage definitions that we provide for that. Along with that, the methodology and infrastructure in RISC-V verification plays a very crucial role for reaching the coverage closure, getting that chip to the market. And finally, if there are customizations, then the verification also has to adapt to all the configurabilities and customizations and quickly develop the verification IPs for that customization provided within the RISC-V environment and bring the whole product to the market. In case of a RISC-V processor, I am presenting the different components that come to play for a RISC full processor verification. Initially, we have tests and the test templates. Here, the test refers to the RISC-V assembly test that exercises any processor design. And test templates are the configurations that we provide to RISC-V generator that generates the RISC-V assembly to exercise the processor. So this complete set provides the whole test infrastructure for the processor. Once the test has been generated, then it gets compiled and the test bench written. Currently, we are proposing a Python-based test bench with any commercial or an open source simulator. It will be exercised over that and simulated. Along with that, at the same time, we have this processor verification methodology where we exercise the same test on the reference model and we compare the states. Either it can be compared in a log-based manner or at every instruction, we get the processor states. For example, the processor state here refers to the general purpose registers or floating point registers or control and status registers. These state comparisons helps pass or fail the test. So this is how the whole infrastructure has been built and have been used by different verification teams for RISC-V processor verification. So in this, the main components here come into picture are the test and the test templates, the test bench using UVM methodology, how we develop it across the design, and very importantly, the reference model at the core level, at the processor level for the state comparison, and also a lot of reference model at the block level for each of the units within the RISC-V processors. Along with that, a very important part of scoreboard, especially at the processor level, as well as at block level, comparing the states of the design. The most important part, which we take for granted, is the tool chain and the infrastructure, which we will be presenting how we make over and use it for RISC-V verification. Of course, every engineer knows how coverage completion or closure takes time and the effort that is needed for that. So we also provide insights in this talk on how to leverage the current software infrastructure for defining and analyzing coverage better. So what is the wake-up call? So we already know the situation. We have a high proliferation of RISC-V processors in the market. We have begun to develop the capabilities on how to verify a RISC-V processor. But according to a survey, we already see with the complexity of the designs that are coming up, as well as the domain-specific applications that are coming up for each design for the differentiation in the RISC-V market, we know that 76% of the designs do not achieve first silicon success. This has implications on the cost of the tape out, as well as the cost of the product, as well as the capability for us to bring the product to market in a timely fashion. And there is also an important information that the logic and functional flaws are the leading cause for these respins. this directly points to us as verification engineers that yes, we have developed the expertise to verify designs. We do know how to verify process designs, but that is not enough. We have to change things to make sure that we meet these challenges so that we make the risk-fi business complete success by providing quality products in a market. So what do we do? That is where we say that the first makeover happens. RISC-V as an ISA is an open standard, and a large community works towards building the capabilities for all kinds of facets in the ecosystem, be it the tool chain, be it the reference model, be it the open source designs, as well as test generators. There is a whole community that is working towards it. So first and foremost, we need to understand that the makeover has to happen in the tests where we can leverage already existing tests intelligently, of course, so that we don't spend rewriting the test, rewriting the scenarios, capturing the same features that might be present in all the RISC-V design. So that is where the ISA brings that abstraction, where the ISA level tests can be configured because the RISC-V itself is configurable, and it can be reused across various RISC-V designs also. So there is a need for having a configurable test plugin, which you can plug and play between different designs and hopefully between different product lines also, so that you bring in that maximum reuse and mm, reconfigurability in the test. Along with that, there is an interesting aspect that you can have this in conjunction with a Python ecosystem, where the test bench is written in Python, which we will explain in the next coming slide. And you can bring in all the learning and the whole rich ecosystem that the Python provides back into the test to have the tests exercise the processor more intelligently. So these are the works that has to be done. It's not something that is ready-made. So that is where Vyoma is trying to build that capabilities in our tools. So we can have the option to have the whole Python ecosystem in our hands, in our tests and test generators and coverage definitions, which can in turn use generative AI techniques, which are becoming popular. We can try and build a very intelligent and faster closure between the tests and the coverage definition. So we still haven't, I think, figured out a verb. So I say the first makeover happens by chatbotting the tests and the coverage. So each feeds the other, and hopefully we can have mostly automated infrastructure that exercises all things that are ISA specific. So it's not just that it's a one single solution. We do have micro-architectural dependencies, which can be different for different implementations. So we first currently target, which is very common and which can be easily reused across different lines. And that is where we say that we can start off with the ISA level test, and we can bring in this kind of a feedback technique that a lot of people can provide solutions to, and bring the coverage and the tests to be as quickly closed as possible. The second makeover is the test bench. So in order to leverage such ecosystem where I mentioned as Python, we need to develop the test bench also in that, so that we can reuse a lot of the ecosystems modules and everything. So second makeover that we propose is to Pythonize the test bench. Here we use an open source library called CocoTB, a coroutine-based co-simulation test bench, which is getting traction recently. So we use that with the combination of Verilator, where we parallelize the simulations as much as we have the cloud, we have the compute infrastructure available. the only question is this infrastructure enough? Does this maintain the verification quality? Yes, we have seen that with our use case, that we do not compromise on the verification quality. We just augment our test bench with an infrastructure that helps us bring in more capabilities that is inherent to the software ecosystem. So what we say is there is possibility of constraint-based randomization also capable with this Python test bench, as well as the different test bench components that we can develop using UVM methodology that we are familiar with. We can define the driver, monitor, and scoreboard as we do in our normal verification, as well as the coverage definition can also be maintained and developed using the same infrastructure. So the next third important from my standpoint of view for today's talk is the tools and infrastructure. So we maintain several projects, and we have different SOC components also maintained within using the RISC-V designs. So in order to have this capability to scale up and reliably maintain the verification quality, we containerize all the components that are needed for each design, because every design brings in its own customization. So we containerize the whole environment with the components, basically the generators, the test templates, the reference model, the simulator, the RISC-V toolchain, and also the coverage definition. So you containerize all these things within the same Docker environment, which we have borrowed again from the software world, and maintain that same infrastructure for development, which the verification engineers will use, and for regression and the production release. This makes it reduces a lot of human errors in having different reference models or different tool infrastructure that creates delay and productivity loss. And also this helps us scale our regression environment, which can only be limited to our either the in-house or the cloud compute capabilities. So this is the third makeover that we propose, that Dockerize our tools and infrastructure for verification. In summary, so what are we making over? We make over the verification infrastructure that provides the verification engineers added capabilities to verify their RISC-V designs faster. The first one being the VIP, the verification IP plugins, which either developed in-house or borrowed from third party very quickly, and build that capability to have generative AI tests for efficiently verifying the design. The second, Pythonize your whole test bench so you can leverage the rich infrastructure that comes with the Python ecosystem and improve your productivity. The third, Dockerize your whole infrastructure so that you can scale your verification and reliably over on-premise compute. This, we believe, ensures high verification, high design quality. Actually, okay, it comes from the verification quality. So it ensures the high design quality, and it makes sure that we have the capability to make the RISC-V design business a success.
Thank you. Lavanya, we're going to have to finish there. Okay.
Yeah. So it's just a few minutes. So we developed this whole infrastructure in the SHAKTI ecosystem, and we have been able to do that.
Lavanya, I think we unfortunately got to finish there. We've run out of time and we need our next speaker now. Okay. Thank you very much.
Yeah. Thanks.
Thank you. We're just going to change our presenter. Hi, Disha. I need to change speaker. Oh, but we've got remote as well, people. Yeah? Are you going to? Okay, you're going to do it for me.
That's the same time.
Okay. This is your one, yeah?
Yes.
I'll just do an intro from you.
Yeah.
Yeah, okay. You comment it there. Testing, testing. Hello? There's a little button there. Do you want to test it?
Hello. Hello.
Okay, okay.
Okay.
Hello, can you hear me? Yeah, it's on the mic. Okay. Okay. So we come to our second speaker this afternoon. I think we're just going to do a presentation from here. Yeah.
Yes. Yes.
Yeah. So we've got two speakers listed, but we're all going to be done here. From Srinivasan Venkata Ramanan from Asvigo Technologies, where he's CEO. He's an influencer and technology entrepreneur with extensive knowledge of semiconductor chip design flow, languages, tools, and methodologies. As CEO of Asvigo Technologies, he is mainly focused on applying open source techniques to address current bottlenecks in the chip design and verification process.
Thank you. Okay, lovely. Good afternoon to all. And first a quick shout out to the organizers, the way they have scheduled these. Is that okay? Something popping up here. So the way it's been organized, I'm pretty happy because the previous presentation naturally leads to the next one. And I'm pretty sure it's British intelligence. It's not AI, it's BI. Thank you.